yellow bird, the word problem says, yellow bird has a launch point of 20. His flight point reaches a maximum height of 20 yards and lands at point 260. So as the word problem states, the maximum height is 20 yards. So that's how I found 20 yards. The distance traveled, you can see that it starts at 2 and then it ends at 26. So to find the amount traveled from 2 to 26, you subtract 26 from 2 and you get 24. And that's the distance traveled in that aspect right there. And so when you're finding the axis of symmetry, you're going to divide 24 by 2 and get 12. So when you get 12, you count over from 2 and you count 12 spaces to the middle and you get 14. And so there's 12 spaces on both sides. And that's the axis of symmetry.
And this is our Angry Birds parabola project. For the blackbird's flight path can be modeled by the quadratic equation y equals negative x squared plus 28x minus 171. So to find x, I put it in the negative b over 2 times a equation and found that x equals 14. And then I plugged the x into this equation and found that y equals 25, which gave us the maximum height, and then since x equals 14, that's our axis of symmetry. To find the distance traveled, I put in I factored the equation to find the points 90 and 19, and subtracted those two to find the distance traveled is 10 yards.
Shelbie. For the red bird, the word problem said, red bird's flight is represented by the graph below. And here's the graph right here. And so for the maximum height, I just went to the top of the parabola and led it over to the left side where it came to 25 as the height. And for the axis of symmetry, I found that from 0 to 32, which is the range of the parabola, if you divide it in half, you get 16, and so that's where the axis of symmetry would be. And like I said, from 0 to 32, that's 32 yards, so that's the distance traveled.
For the bluebird, the table below contains partial data points of bluebird flight frequency. So the table goes up from 24 to 25 back down to 24. So knowing that parabolas are symmetric, I filled in the rest of the data by going backwards with what is already in there. I found that the maximum height was 25 yards, the axis of symmetry is 7 yards, and the distance traveled is 10 yards. And then down here, we found out that the red bird flew the highest and traveled the longest because both the maximum height and the distance traveled surpassed the other birds.
Okay, and we found that the blackbird was the one that hit both the king pig and the mustache pig. And we found this by plugging in everything into the parabola equation, which is right here. So we plugged in the coordinates of the blackbird, 1425, which we got from the maximum height and the axis of symmetry. We plugged it in for h and k, and we solved to get -1 as a. So once we got a, h, and k, we plugged in the x and y coordinates of the king pig, so all we had to do was solve for y. And when we solved for y, it equaled 24, and the coordinates of the king pig was 1524, so when we plugged both of those in, it turned out to be true, that it hit it. And we did the same thing for the mustache pig. We plugged in 11 to see if we could get 16, and we did get 16, so that means the blackbird hit both of the birds.